last topic before we start normalization. So we need to study what are prime attributes and what are non-prime attributes and what are non-prime attributes. Then in this video, then we'll be studying what are partial functional dependency. What is a partial functional dependency? Next, what is a fully functional dependency? Fully functional dependency. And the last one is what is a transitive functional dependency? Transitive functional dependency. Okay, so it is partial functional dependency, fully functional dependency, and transitive functional dependency. So we'll start with what is a prime attribute. See, when I'm saying prime attribute, these are the attributes which come in the key, or you can say candidate key of a relation. Then those attributes are called as prime attributes. Assume we are having the relation R, A, B, C, D, E, and F. This is a relation which is given. Now in this relation, these are the functional dependencies which are given. C determines F, E determines A, EC determines D, and A determines B. These are the given functional dependencies. Okay, so what is a prime attribute? You can say prime attribute is the attribute which are present in any of the candidate key, and non-prime attributes are the attributes which are not present in any of the candidate key. Okay, so let me write this definition here. When I'm saying prime attributes are the attributes which are present in any of the candidate key, and non-prime attributes are the attributes which are not present in any of the candidate key. Okay, now for this given relation, find out what are the candidate keys which are possible. For that, look at the right hand side of each production and see what are the variables, or what are the attributes which are not present. Here F is present, A is present, D is present, B is present. Only C and E, these two attributes are not present. So in any candidate key, EC should be there. So E and C should be there. So if we take EC closure, let us see what are the things which we are getting. If you take EC closure, it is going to give EC because it is trivial. From E I can get A, from EC I can get D, from A I can get B, right, and from C I can get F. So if you take EC closure, that means you are getting all the attributes in EC closure. That means for this given relation, only one candidate key is possible. If you add anything else in EC, then it will become a super key, it will not remain a candidate key. So this candidate key is also a super key. Okay, so if you add something else and it will become a super key, then it will not be a candidate key. Okay, so the EC is the candidate key here. So there's only one candidate key, and the attributes which are present in this candidate key are E and C. So you can say E and C are prime attributes. All the other attributes which are not prime, they are non-prime attributes. For example, a part of E and C, we have A, D, B, and F are non-prime attributes. Non-prime means these are the attributes which are not present in any of the candidate key of this given relation. Okay, now you understand what is a prime attribute and what is a non-prime attribute. Now next is what is a partial functional dependency, fully functional dependency, and transitive functional dependency. Partial, fully, and transitive. Let us discuss about them. So we have the following functional dependencies. Number one is fully functional dependency. Second one, what is a partial functional dependency, and third one, what is a transitive functional dependency. What is a transitive functional dependency? Okay, so assuming that we have X determines Y, where X is some set of attributes and Y is some set of attributes. Okay, so you can say Y is said to be fully functionally dependent on X if it cannot be, if it cannot be determined by any subset of x, any subset of x, then it is called as fully functionally dependent. But if can be determined by, if it can be determined by, if y can be determined by any subset, any see, when I'm saying subset here, that means I'm saying about proper subset. Okay, any proper subset of x, then it is called as partially functionally dependent. Okay, so for example, let us assume we are having the following functional dependencies. They are a, b, c determines d. Now if we say for this given functional dependency, when can we say this it is a fully functional dependency? If any of the subset of this left hand side cannot determine d, then you can say d is fully functional dependent on abc. That means we cannot have the functional dependencies like ab determines d, or bc determines d, or ac determines d, or a determines d, or b determines d, or c determines d. We cannot have any of these functional dependencies. Why? Because all the left hand sides are actually proper subset of this, right? If any proper subset of this can determine d, then it is called as partial functional dependency. If any proper subset cannot determine d, then it is called as fully functionally dependent. Okay, so these things cannot happen. Now let us take this example. If we are having ac determines p, and a determines d, and d determines p. Okay, now if you check the first function, this first functional dependency, we have ac determines p. Here can you say p is fully functionally dependent on ac? Fully functionally dependent on ac. How will you check? Take the subset of ac. What are the subsets of ac which are possible? Subset is a and c. Now take a closure of this subset. If I take a closure, then it will be a, d and p. If I take c closure, then it will be c only. Now from a subset of this, if I'm in a closure, if I'm getting p, that means I can write a determines p. That can also be verified from here. You can see if a determines d and d determines p, therefore by transitivity a determines p. Okay, so you can say this p is partially functionally dependent on a, therefore this p is not fully functionally dependent on d. Okay, so you can say p is not fully functionally dependent on ac. P is partially functionally dependent on ac. P is partially functionally dependent on ac. And next is, what is a transitive functional dependency? What is a transitive functional dependency? Transitive functional dependency says if x is some set of functional dependency and y, x, y and z are some set of functional dependencies, some set of attributes, then if x determines y and y determines z, then x determines z. Now this x determines z is transitive functional dependency. It is called as transitive functional dependency, right? So now we are going to introduce normalization. In case of normalization, we will try to remove these functional dependencies only. So now let us look at the next part, how in what normal form we remove these functional dependencies, and what is the specific functional dependency which will be removed in a specific normal form. Okay.